In this lesson, we are going to go over what's called direct and inverse variation. And if you are unsure what those two things are, no worries. I'm going to go over that stuff with you right now. So when we're dealing with direct and inverse variation, direct simply means that as one thing changes, as our x changes, our y changes with it. And if you remember what a graph is and how that works, we have an x variable and a y variable, both of these things changing, and we plot those to see how these things are changing, a rate of change. That's what the slope is. That's kind of what our k is going to be a little bit, but not quite exactly. When we look at direct variation, we see here on this graph that as k or as x and as y get bigger, our k also gets bigger. Our k is what's called our ratio of variance. Okay, so when we're dealing with direct variation, which is the first one that looks like a normal line, something that's pretty simple that we're used to dealing with, like the straight line here. And this one actually should have a negative sign on it. So let me go ahead and fix that. I suggest you fix that on yours as well. And once you fix that, you will be well on your way. So we've got this y equals kx for a positive slope, and then y equals negative kx, right? I'm just gonna have to throw a negative there. All right, y equals negative kx. That's when we have direct variation, okay? Direct variation means that as x goes up, y goes up. As x goes down, y goes down, or whatever our variables are in there, okay? Whatever our variables might be. Now, when we look at inverse variation, and actually before we move on, the formula for direct variation, which is going to be really important as we go on, is this right here, y equals kx. Let me change this size again. Y equals kx. This part, we're going to use this a lot in this lesson. Y equals kx. Real quick, well, I'll do that below, never mind. That's for direct variation. For direct variation, y equals kx. Now we're dealing with inverse variation. That means as x goes up, y goes down, and as x goes down, y goes up, which is why we get these really funky looking graphs like this, okay? And once again, this should be y equals negative x or negative k over x, just as this one is y equals negative k. All right? So inverse variation looks very, very different than what we're used to seeing, but we kind of know what it's about a little bit. But now let's look into how we can find these things using the stuff that we know. All right, so when we're given some information to determine our direct or inverse variation, our first step is going to be to make a table. That's what we have over here, just set up. Once we have a table, we're going to set it up and fill it up with the information that they give us. And oftentimes the information is already in the table, so we don't have to worry about that too much. But if it's not, we can put it in the table and work from there. And then it says determine which column has the same values for every row. And that's talking about our variance, our k. And then we're going to write the corresponding equation substituting k in. So if you look back, the two things that I highlighted earlier, they're also in the spot that we're on. That's really bad. Underline. They're also in this spot here. So we have direct variation is y is equal to kx, and then we have inverse variation, which is y is equal to k over x. We have these things show up here. Y is equal to kx. And then when we solve for k, which is what we really want to be solving for in these, to figure out whether something's going to be direct or inverse if we're not looking at it directly in the graph, then our formula to find the variance is going to be k equals y over x for direct, and then for inverse is going to be k equals x over y, okay? I usually deal with those formulas for variance, k and k for both of those, as opposed to the direct and indirect, y equals kx and y equals k over x. As long as you remember either of them, you'll be good to go for whichever it gives you. All right, so let's look at an example. This says make a table. So let's pick some numbers here. Let's go with 1, 2, and 3. And then for here, let's go with 2, 4, and 6. All right. Now, when we go to look at whether this is direct or indirect variation, one of the methods that we can do is to solve it just mathematically. K is equal to, we're going to substitute this in. I'm going to write it for this first one, but I'm not going to write it each and every time. I'm going to write K equals. And then the formula for direct is y over x. So 2 over 1. 2 over 1. That's what that one's going to be. This is going to be 4 over 2. And then this third one is going to be 6 over 3. All right. When we do 2 over 1, we get 2. 2 divided by 1 is 2. That's pretty simple. When we do 4 over 2, once again, we get 2. And then when we do 6 over 3, once again, we get 2. Now look, this is it. It says determine which column has the same values for every row. That's the important part. That means that variance factor, that K value is the same. It's not going to change. Now, if we go to try to solve it with something where with one of the formulas that doesn't work, so this one we can see that it's direct, and I'll explain that in just a minute. If we try to solve it with indirect or with inverse, I'm sorry, then we'll see that it doesn't quite work out as nicely. So if we did K equals, and actually I'll do this one in a different color to showcase the difference between inverse and direct. All right, so K is equal to X times Y, which is going to be 1 times 2, and then 2 times 4 for the second one, and then 3 times 6 for the last one. 1 times 2 is 2, right? Then 2 times 4, that's going to be 8. Then we have 3 times 6, it's going to be 18. Now we can see here that the K values aren't the same on each column or going down the column for inverse because we chose the wrong formula. So if you happen to choose the wrong formula to try to solve for whether it's direct or inverse, you'll see because the K values won't be the same. All right. So now once we've determined which column has the same value for every row, we're going to write the corresponding equation substituting that K value. All right. So our formula is y equals kx. So now what we're going to do is use the K value we just got from solving, which is this 2 here. Y equals, for this set of points, for this bit of data, y equals 2x, because 2 is our factor of variance, okay? 2 is our factor of variance. So just a quick recap before we move on. We have direct and inverse variation. When something varies directly, that means as one goes up, the other one also goes up, and we'll usually see a straight line with that. If as one goes down, the other will also goes down. That's what we see usually a positive slope or a negative slope, like this up here. Positive slope, negative slope. When we have things that vary inversely, we get these weird looking half U's or outturned circles or something like that, that don't look like what we're used to in a graph. And that means as x is going up, y is going down. Or as x is going up, or as x is going down, excuse me, y is going up. They're not going in the same direction. They're going in opposite directions. And the way you can tell, look at this. If you go from left to right, we usually read graphs. This arrow says x is going out this way to the left, towards the negative numbers. But as x is doing that, our y value is going up to the positive numbers. Those things are going in opposite directions. If you just kind of follow that trend with the rest of these, our x and our y are going in opposite directions for there. Okay, so that's just kind of a quick overview. Now, when we're looking at these things in the table format, we don't need to always do the steps, but when we're looking at them in the table format, here is another little method that you can use. Looking at the table, once you look at the x values, start off by looking at x values, I should say, 1, 2, and 4. All right, those are going up. From 1 to 2 is an increase, from 2 to 4 is an increase, right? Then if we look at these y values, from 16 to 8, that's a decrease. And then from 8 to 4, that's also a decrease. So we see our x values are going up, whereas our y values are going down. And since we see that, we know this is going to be inverse. Okay? That's a whole lot quicker way to do it than solving it the way we just did above. But we're still going to need that information. So that's just kind of a quick little method. Now let's actually read what the directions say and do what they say. It says determine whether the following tables are direct variations or inverse variations, and then write the equation. All right, so what this is asking for when it says to write the equation is going to be that y equals kx or y equals k. Y equals k over x. Okay, it's looking for one of those. Now, we just saw with this first one that it's inverse because our x values are always going up and our y values are always going down from the values given in the table. The next step is going to be to do what we did above. Since we know it's inverse, we can come up here, we see it's inverse. We're going to use our inverse formula, that k equals xy, and that y equals k over x. I'm going to start with the k equals xy, so I don't have to solve for y first. If you use the y equals k over x, you'd have to solve for k and then substitute your stuff in. All right, so since we have y equals k over x, I'll have it written down here, so I'll use that version. K is equal to and if you don't want to use this version, you can always scroll up because it is written right here. K is equal to x times y. And if you go outside the lines, it's not too bad. So on this first one, k is equal to x times y. 1 times 16 is 16. 2 times 8 is also 16. And 4 times 4 is also 16, okay? Now, I'm going outside the lines, but I do recommend you all stay inside the lines and keep it kind of looking decent and neat. So now that we know our factor of variance is that k value, we're going to plug it into this equation for inverse variations, y equals k over x. And that's just going to be y equals, our k value is 16 over x, okay? And the reason this is important is because sometime later on in these notes, we're going to have a y and x. We're going to need to find a k. And we want to be able to use our formulas like this. So you kind of need both, but right now this one is the k version is what's easier to work with. But later on we'll work with just the y equals. All right, so let's look at number 3. You all will do 2 and 4. Number 3 says goes 1, 2, and 5. So those are going up. And that's what I recommend. When you're solving these from the table, go ahead, look at the x values in the table, and then write an up or down arrow next to the x for whether those values are going up or down, whether they're increasing or decreasing. And then this y, we have 10, 5, 2. These are also going down. All right. My next step is going to be to set up my k equation. So k equals x times y. And we get that because y is equal to k over x. Excuse me. And I'm going to substitute my values in here. 1 times 10 is equal to 10. And then we've got 2 times 5 is equal to 10 as well. And then 5 times 2 is equal to 10. Once you do that first one, the other ones are just to check to make sure you continue to get that same k value. If you get a different k value, that means you chose the wrong equation to use to check. All right, so since we have this 10, we have k equals 10 all around, and we write out our equation. Y equals 10 over our x. All right, you guys do 2 and 4. Next, let's look at number 5. It says if y varies directly as x and y equals 72 when x is equal to 8, find x when y is 63. So this initially seems like a lot, but it's not too bad at all. First, I'm going to take the time to fill in my table just because I like the way the fill-in table looks like. So remember, y is equal to 72. I don't want to write my y in my x spot. I want to write my y in my y spot. 72, and then x is 8. And then we have 63, and we're looking for this section here, this number. So it's giving us an x and a y. So we're going to use that x and that y to find our k. To do that, we read it again to check to see what we're getting. It says, if y varies directly, that part right there is really important. That tells us exactly what to use. If y varies directly as x, and y is equal to this and that and that. So now I want to go look at my direct variation formula, which is y is equal to k times x, okay? Y is equal to k times x. So I have y is equal to k times x, and we want to find this k, okay? Because we need that to find our x. So now that we have our original equation, y is equal to kx, we need to solve for k, and k is going to be k is equal to y over x, all right? And now that we have that, we can use the values and the numbers that it's given us to solve for k. So we have a y and an x. We've got the 72 for y and this 8. I'm going to substitute those into this equation. 72 over 8. You can go ahead and type that into your calculator, and what you'll get is 9. If k is equal to 9, we can use that information to set up this original equation. See here, we're going to be using both of them, not just one or the other, to find our x when y is 63. All right, so we know y is, and let's go ahead and do this in a different set of colors. So y is equal, let me bring it up a little bit. Y is equal to k x. We have a y, which is 63, is equal to k, which is 9, times my x. To solve for x, you divide by 9. And this is a pretty easy one right here. If you guys know your times tables, you know 9 times 7 is 63. So 63 divided by 9 is going to give us that x is equal to 7. All right. So we come over here. We know that it's not a question mark anymore. It's a 7. All right. That's that entire process. Now I'll do number 6 to show you what it looks like for varies inversely. So number 6 says, if y varies inversely as x, if y, or y varies inversely as x, if y is equal to 3 when x is 12, find x when y is 4. So once again, our first step, go ahead, anytime when you're doing these, always underline what that variance is. It's varies inversely or directly. So I'm going to look back up just to check to make sure I know. You all should always check to make sure you know. Inverse variation is y equals kx, or y equals k over x, okay? So y equals k over x. Now that we know that, we have to solve for k, and that's also up above if you want to look at that. K is equal to xy. It's underneath the inverse spot in the column. K is equal to, I'll do it right here, xy. And we want to find k. We have our y is 3 and our x is 12. We have another y is 4, but we don't know what this one is. So we have a 3 and a 12 to work with. So k equals 3 or 12 times 3. That's going to be a good old 36. Easy maths right here. And so we're going to use this k value to find our new x. So we have y equals, let me go to the change colors for that one. Y equals k over x, 36 over x. Instead of having that y though, we have a y value that we can use, which is 4. So we're going to use that instead. 4 equals 36 over x. Okay? And if this is confusing, remember you got to do some working around times x on both sides and divide by 4. But instead of doing it like that, I'm just going to go ahead and flip-flop them because that's what you will get anytime you do that. These two things switch. They switch places, and we end up with the x equals 36 over 4, and that's going to be 9, okay? If that step was confusing for you, go ahead and just work it out, putting the x up and then putting the 4 over, okay? You all do 7 and 8. And finally, I'm going to do number 9 and then number 11, and we will be done. Number 9 says, place 2 additional points on the graph of the direct variation that goes through the given point. You know what? Actually, I'm going to save number 9 and 10 for you all. I want you all to use your context clues of what it gives you. I will give you a little bit of a hint. It gives us an x and a y, and it tells us, oops, direct variation. Okay? That honestly is enough for you all to go ahead and solve it. If you run into some problems, let me know, but you should be able to get it from there. Now we have the dreaded word problem. It actually is not that bad. The same way we did it above with those descriptions using words, the same way we're going to do it down here. It says, first off, read the question. The circumference of a circle varies directly with the length of the radius. When the circumference is 16 pi inches, the radius is 8 inches. What is the circumference when the radius is 5? All right, so this has a lot of distractor words in it. Don't let circumference confuse you, or pi, or any of the extra things. What you need to know is that varies directly, and then you can go ahead and just take the C, or you can make this Y and then this X. We'll use C and L, since those are the letters of the first word. So C varies directly with Y, all right? Once again, if you don't remember what that is, varies directly means direct variation. K is equal to Y over X, or Y is equal to K times X. So since C varies directly with Y, it's going to be C is equal to, C is equal to K times L, right? And then once again, you're going to have to solve for that K value, and that K, which is what we're going to end up needing, is going to be equal to C over our L. All right, before we even work with any of the numbers, that's what we need to do, right? Find out whether it's direct or inverse, write your original for direct, and then write your K. Your original formula, which is the Y equals KX or C equals KL, whatever you're using for that. Use that, write that out first, and then write out the K portion of that. The K is equal to C over L, or K is equal to Y over X. And now here's what we're going to do. We're going to actually substitute these things in. So it says when the circumference is 16 pi inches, the radius is 8. We're going to use that right there to find our K value. So K is, we have C over L, and then it's given us 16 pi over 8. All right. Now, I don't know about you. I don't know what 16 pi over 8 is right off the bat. So I'm going to go ahead on over to my decimals tab, and let's go ahead and type it in. You may want to bring up your keyboard button because it has pi there. Go ahead and type it in 16 pi over 8. And it's 6.283. I'm going to go with 6.3. Right. So K is equal to 6.3. All right, what is the circumference when the radius is 5? So we have our K value, and we need to find the circumference now. So C is equal to, actually, let me do this part in a different color again. C is equal to KL. We know our K. So in this time, C is going to be equal to 6.3. And then when the radius is 5, so it's going to be simple multiplication. 6.3 times 5. And I don't know that right off the top of my head. And if you don't know, you go ahead and use decimals. It's a tool that we have provided. So use it. 6.3 times 5, 31.5. Bada boom, bada bang, it's all done. All right. C is equal to 31. Oh, goodness. 31.5. Okay. You all go ahead and try number 12 on your own. If you run into problems with that, let me know. Come back to the Zoom chat, ask any question you may have. I'll answer them there. And once you're done with this, work on the answers, all right? If you have any other questions, let me know.